Hi everyone, great to have you. This is the second Stellar workshop in the Encode Hack Africa program. We're delighted to have Tyler here, who is an ecosystem engineer at the Stellar Development Foundation. To talk you through all things about how to start developing on Stellar. If you're a beginner, this is absolutely perfect. And if you're even a little bit experienced, that's absolutely perfect. This is absolutely perfect to talk you through everything. Please, if you do have questions, put them in chat, and you can also find all the support you need in the Hacker Pack, which you should have. If you don't have, message us, and also in the Discord. Tyler, we're delighted to have you and ready for you when you are for the talk.
All right, super duper. Thanks so much for having me on. As mentioned, my name is Tyler Vanderhoeven. I'm the ecosystem engineer at the Stellar Development Foundation. I fill my days with writing documentation, doing workshops like this, playing around with Stellar essentially, running things like the Stellar Community Fund, which is a funding program for people looking to build applications or businesses on Stellar, as well as Stellar Quest, which is a little bit more of a gamified, lower prize, but you can still get lumens for learning Stellar, doing development, things like that. I really enjoy what I do. Today, we're going to be diving into one of my favorite talks, which is getting started on Stellar. So this is going to be for developers. We're going to be focusing on the JavaScript language and hopefully give you a solid overview of how to begin using code to the JavaScript language to interact with Stellar and start making transactions and using the Stellar blockchain for your business logic. And there's a picture of me. All right, so we're going to start with an introduction. We'll walk through the Stellar stack, the different components that are available to you and how they interact, ending with the Stellar SDKs, which are kind of these functional wrappers that we have around different languages. We'll be using the JavaScript one as mentioned, but we have several different ones, different languages that we support natively, and new ones are being built all the time by members of the community. And then we'll get into some application stuff using those SDKs to explore this idea of delegated signing, which is essentially how to take a wallet, how to take keys, and use those in applications without actually having ownership over every key. So this concept of non-custodial, you're not owning all the keys of your users. You're using a wallet. I don't know if you guys have used MetaMask or something like that before. We'll be exploring that a little bit, and then we'll end with building a very basic application, tying all of these pieces together, and then end with questions. So as you have questions, feel free to write those down, put them into chat, and we'll go through those closer to the end. Stellar, like most blockchains, has a network of nodes, this idea of simply a database that's keeping track of a synchronized state. What makes blockchain cool isn't that it's some technology really that's never been used before, but using technology we've always had and scaling it out to where you have a distributed ownership, but everybody agrees on the state. So you've got a database. In Stellar's case, it's a Postgres database that all of these nodes are agreeing on the state of. So the account balances. That's the network, the process that you're kind of having this chain of events of everything changing in a very specific way. At the end of the day, you have agreement around the state of the database. And that's all happening at the node level, at the Stellar core here at the bottom of this graph here. Stellar core, that's where if you're ever going to set up a node or run a validator, you'll be dealing at this Stellar core level. All of the applications, though, all the entities, applications, users they're interacting with, they're taking advantage of this technology of a distributed, agreed, synchronized database. All those applications that are making use of that are interacting with the Stellar core, interacting with the network through an application or a service that we call Horizon. And this is simply, it's almost a reference implementation. You could build lots of different types of this, but we have one that the SDF builds and maintains called Horizon. And this is an API, a public API layer that connects you to the Stellar core in a very digestible, human readable, sane representation of Stellar Core. So we use XDR format. So that's the encoding method that we use. So all of the data that's getting translated, the account states, et cetera, in the Stellar Core Postgres database are encoded with an XDR format. Horizon's going to take that XDR format and turn it into something that's actually usable on the front end, so JSON. So this is going to be the way that you get access into Stellar Core. So this is both reading data from Stellar Core and also putting new transactions, proposing new transactions into Stellar Core. Your interaction will be through Horizon. The SDF and a couple other entities operate public Horizon endpoints. So we won't have to set up any nodes. We're not going to need to run our own validators. There's no complex DevOps going on right now. The only thing we're going to need is this Horizon API URL that we'll interact with, and then a bunch of documentation and the SDKs, which will actually allow us to connect through Horizon to Stellar Core to begin to actually submit transactions, read data back, et cetera, et cetera. So that's actually kind of unique to Stellar. Not every blockchain has this publicly available API layer by which you can interact. You have to set up nodes and then directly interact with the core layer of the blockchain. Stellar moves that one layer up to make it much easier for people to get started and begin interacting in a very familiar interface like you would with many other financial APIs. What we'll be spending our time with mostly today are the Stellar SDKs. So we have a whole bunch of these. If you go to developers, let me actually drop this out really quick and we'll go there. Developers.stellar.org. There's a software and SDKs tab right here that shows you all the different languages that we support. So at the end of the day, Horizon is just a bunch of HTTP REST API endpoints that spit out JSON. So you don't have to use an SDK at all, but it will make interacting and kind of reduce the amount of code that you have to write to interact with Stellar if you use an SDK. But there's no reason that it would be required. But if one of these languages is one that you're using, using this SDK would be a great place to start. Again, if we'll be working with the JavaScript one, so that's our source and then our docs, which I'll go ahead and pull that. This would be the source code for the JS Stellar SDK. This is kind of a good landing spot. So if you go to stellar/JS Stellar SDK, or even just go to Stellar, I think we have it pinned up at the top. You can submit any issues that you find, submit changes as needed, ask questions, and then also there's lots of good documentation on where to go for documentation, how to install it in different environments.
Sir, I want to ask one question.
Yeah, go ahead. All right, we'll save questions for the end. If you have questions, feel free to write them down either in the Zoom chat or just keep a note of it, and we'll answer questions more towards the end so that we keep moving along. So we've got our GitHub repo and then the SDK documentation. This is going to be the lifeblood. If you are using the JavaScript SDK, this is the place where you're going to be spending the most time looking at all of our different operations. The navigation here, I'll be honest, is a little bit wonky. So a lot of times just doing a search for things. So if you're in the documentation, this is just kind of a pro tip. If you're in the documentation inside of the API reference, this is if you're interacting with Horizon kind of raw without a SDK, you'll get all of the different formats for things. You can use these as keywords that then you can enter into whatever SDK documentation you're using. So if we go to something like back in the documentation, we go to this list of operations. You can see all the operations that Stellar can perform. So things like create account. You could type in something like create account here and it'll pop that up for the operation. So you can get all the different keys that you need when you're doing the create account operation, which again, may not make a ton of sense yet. We'll get into that more as we start getting into our examples. So that's our SDKs and Stellar documentation. Next up would be the documentation that we just covered. And then for the delegated transaction signing, there's quite a few different applications you can use. We'll be focusing on albedo.link, which is an open source, non-custodial wallet. I'm gonna go ahead and open that really quick. This one's fantastic for actually integrating a wallet directly into your application. You can generate keys for users and never actually have to touch their secret keys. And this is a big deal when building applications because there's a lot of custodial concerns that come when you have the rights or the ownership over all of your users' secret keys. Using something like Albedo allows you to delegate that secret key management over to your users, but still have this sort of delegated signing access where you can compose a transaction, compose a payment, whatever you need to have the user do, you can compose that and then hand it over to them to sign it, right? Because everything in a blockchain revolves around instructions that then get signed by some owner. So you've got a public key where all of the instructions kind of get sent, where I want this public key to make a payment or add a signer or add some data to the account. I want it to do something. And so I can compose that, but unless I can get it signed by the public key owner, the secret key of that public key, just composing it is useless. So your application, your service can compose a transaction, then hand that over to this Albedo wallet, which will then present it to the user, and then they can sign for it, which will get that transaction signed such that when it's submitted to the blockchain, it won't error, right? It'll say, okay, this is a transaction which is requesting a payment from this account. That account has, in fact, signed for this operation. Therefore, we will ratify it. We'll actually make it onto the blockchain and make the payment happen. All right, so that's kind of a very quick run through of our SDKs and documentation. I want to spend most of our time actually slowly working through building an actual application. So where we're going to integrate an SDK into our application. So let's go ahead and I'm going to open this. You do not need to follow along with me. Don't try. Just kind of keep an eye on my screen. I'll provide these links to everyone at the end so that you can clone these links and kind of get started working on what I have on your own. For now, we'll just follow along. I'm going to comment this out for now, and we'll just start with our SDK. So I'm using a service called RunKit. This is just a node environment, IDE, kind of an online IDE code editor. And we're going to import the Stellar SDK NPM package. So it's this node environment that allows you to import all of these different node packages. So super, super nice for getting up and running really quickly on a new project if you're just kind of testing things out. And within that, we've got all kinds of different classes. The main one, or the first one we're going to use is just this key pair package. And this is going to allow us to create a new key pair. And all of these things, these SDK methods are mirrored in the laboratory, the Stellar laboratory. This is kind of our playground for testing all of your different Stellar related projects, and all of the endpoints and things that you can do are mirrored here in this laboratory. So rather than having to write any code, you can actually do everything manually right inside of the laboratory. This is a fantastic tool. And what we're going to be doing right now is generating this key pair. Something that trips a lot of people up is thinking that generating a key pair actually does something on the blockchain. It doesn't. These are just valid public-private key pairs. But until I actually get it on the network by funding it with some base level of lumens, it doesn't actually exist on the blockchain. So I'm not actually creating keys on the blockchain. I'm just generating valid key pairs. So that's what we're going to do first, because to be able to interact with the blockchain at all, the Stellar blockchain at all, you're going to need this public-private key. You're going to need an account of some sort to be able to add money to it, to make payments. All the things that you can do with Stellar are going to revolve around this sort of ecosystem of accounts. And so that's what we're going to do first with our SDK. And the way we do that, I'm just going to assign this new key pair to a constant key pair. And we're just going to create a random key pair. So that's what this button here is doing. is just doing key pair random and getting us a new valid public-private key pair. And you can find this if we go to our, close that for a minute, and this, if we go to our key pair class, we can see that it's got a couple of different methods. One of these is random, and it just creates a random key pair object. And that's what we want. If we console log this out, we'll see that it's an object that contains the type of key pair that it is, the secret seed buffer, the public key buffer, the secret key buffer, which obviously these are not buffers, they're strings. So if we want to actually get the strings for those, we would do const and this is documented obviously as well. We've got a method here, public key, which returns the public key associated with this key pair object. And now we can console log this, and we should get that more familiar string. So if we keep running this, we'll get a different key pair each time. Now, like I mentioned, this isn't actually creating this. If we go to the blockchain here and we look up our accounts, we'll notice that it's a 404. It doesn't exist. It's a valid key pair, but it hasn't been added to the blockchain. There's no funding that's associated with this account. So it doesn't exist yet. It's valid, but doesn't exist. Another thing worth calling out is we've got different environments. Right now we're running on the test network. You could switch over to the public network, but that's going to be consuming real live lumens and assets. And then if you run your own Stellar Horizon, you could, or you're using someone else's public Horizon that they've made available, you can put that in here. But we'll just be using the test net for today. So the next thing we need to do is get an account funded. So the way we do that, if we go over here, you can see we've got this friend bot, which funds a test network account. So if this account, again, does not exist on the blockchain at the moment, but if we go and fund it with our test network lumens, we've successfully funded it. And now if we explore this endpoint again, it should exist. Yep. And have 10,000 lumens. So this would be on the testnet, how you would bootstrap an initial account. On the public network, you might go to an exchange or something and swap out your native currency for some lumens to start your project, or enter Stellar Quest or the Stellar Community Fund. And as you place or win in those, you can get some live public network lumens that way. But for testnet, the friend bot's a great way to get some free lumens. We'll go ahead and we've got a little SDK method to do that here. So let's make sure we actually console log the public key. Actually, let's console log this secret, because I don't want to keep creating new accounts needlessly. So we'll console log the secret, but then we'll take the server, which we haven't created yet. So let's go ahead and make a server. This one essentially allows us to connect to, it creates a server class. So if we look up server here, it takes a new server and then the server URL. And this will allow us to interact with that server through the rest of our calls. So up above here, I'm actually going to put this const server equals new server. And then the URL that we'll put in here is this testnet horizon. If I actually show you this here, you can see this JSON string. This is the base route for the horizon, this testnet horizon account. So that's the one we're going to use. So we'll go ahead and pop that in there. Now we've got a server class ready to be used that we can then say, hey, on this server, I want you to call up friendbot, take the public key of this key pair that we just generated, and this friendbot method will actually fund that account. And I'm going to console log the secret so that I can change this block here. Instead of using random, we'll load up from the secret that we just funded. So that's our secret key. And we just funded this account. And it should give us a transaction hash, which we can, just for funsies, go ahead and look this up. So we go back over to our laboratory. Let's look up our transactions, a single transaction. So we were on the testnet server, and this is the transaction hash that it said it submitted. And so inside of this transaction, we're probably going to see a collection of operations. If there's one operation that was submitted, wonder what that operation was. Let's look up our operations for a specific transaction. We should see the operation was an account created, create account, and we should get the public key or the public string, the public key for the account that we just created, and then the number of lumens that we funded. So if we look up this single account for that, we should see that this has got our 10,000 lumens in it. Whoops, that was the account that actually funded it. That was the account source. What we need is not the funder, but the account that was funded, which is this Z3. And so this is the one that should have 10,000 lumens. Nice. So now over here, rather than creating a brand new account, because right now, whenever we run this, it's going to go through the whole process again and create us a new account. We've already funded a nice new account. So rather than loading up from random, we're going to load up from a secret. And that is our secret. And so when we run this again, it should actually show the exact same secret and then error out here because the account has already been created. So it should throw a, hey, you can't create an account that you've already created. Yeah, so we get a nice bad request. We could make a prettier error, but that works well enough for now. So we don't need to fund it again because it's already funded. We also don't need to log the secret key anymore. Now what we want to do is actually take this account and do something with it. So this is where all of the operations that you can do come into play. So over on build transaction, you've got a whole list of operations. Stellar is a non-Turing complete blockchain, which allows it to be very fast and very cheap because there's a very limited number of things that you can do. There's a whole lot of composable things, so you can mix and match all of these things. A single transaction can have up to 100 different atomic operations, which means it all succeeds or it all fails together. So you can, in a single transaction, do a whole lot of stuff, but it's only ever going to be a mix or a singular of any one of these things. So first, I think the most obvious one is probably make a payment. So that's what we're going to do. And let's go ahead and do this in the laboratory first, just to kind of showcase what we're going to be doing. And for that, we're going to need the public key and the secret key. So we already have the secret key, but let's console log our public key. And this should look familiar to what we've seen, that Z3N account. So that's the account that we're talking about up in the source account. So we're going to build a transaction for the source account. We'll get the sequence number for it. And you can start to see where the SDKs become really nice because it can obfuscate away a lot of the additional things that you might need to set up. It handles managing sequence numbers on its own. While you can override sequence numbers and base fees, those things can be handled automatically by the SDKs. We don't need a memo right now, but you could add a memo if you needed it. You could add time bounds if you've ever worked with JWTs. This is the NBF, the don't use this before a certain date or only use it up until a certain date. So if you need time bounds, you can set those up. We're going to leave that for now, and we're just going to make a payment. You can make a payment to any account that exists. If you try and make a payment to an account that doesn't exist, it will fail, and you'll need to do a create account instead. But if the account exists, you can make a payment. I'm actually just going to make a payment to myself, which will effectively result us net zero minus whatever the base fee is. So we'll lose some fees for actually making the transaction, but we won't gain because we're both spending and receiving. We'll just do 100 of the native XLM currency. The source account is optional. It'll just assume the source account of the whole transaction. You can see you've got its kind of base transaction settings and then individual operations. And this would be the first one. You can add up to 100 operations. So if I wanted to have a source account that was different than my operation account, I can do that. But in this case, I want them to be the same. You could fill that in if you wanted to, but there's no need. And now we need to sign this, right? So anybody could go and create and say, haha, I'm going to take this account and I'm going to pay myself all of its money. Super duper, well done. You've accomplished nothing until you can actually get it signed. So this account needs to sign for this operation of making a payment. And you guessed it, we need to use the secret key that we set up in the run kit. So now we've got a transaction that's signed. And you can see this XDR format, this encoded XDR format. So if we viewed that in the XDR, you can paste in that and see the information about it, where it's got the operation, it's got the source count, fee, that sequence number that we set up. There are no time bounds, no memos, one operation for paying itself 100 lumens. And there's no source account, so it's going to assume the source account of the transaction, and then it's been signed with this one account. So when we go to submit this transaction, we can go ahead and click that, and it will submit the transaction to the actual network. So just like that, we've made a modification to the blockchain itself. And now this account should be 100 lumens poorer and 100 lumens richer, which is a net zero minus that fee. So we'll notice that the transaction went, or the balance of the account went down by that transaction fee, but that was all that it lost. And if we look up, go back to that submit, if we look up the hash for this, go back to that explore endpoints, operations, let's actually do effects. So this is breaking down all of the pieces of that payment, not just the final operation piece of it, but for effects for transaction, the effects were that the account was credited 100 lumens, so it received 100 lumens, but it was also debited 100 lumens. So it received 100 and then it also paid 100. And that was a single operation that removed from us that 1,000 stroops. Fun fact, that's what a single smallest base fee, or that's what a single smallest lumen decimal place is. So you've got 1 lumen, but then it's all the way at the 7th decimal place is a stroop. So it removed 1,000 stroops because that's what we set it to potentially remove via the base fee. Okay, so that's how we do it in laboratory. Let's walk through really quickly how we would do that with the SDK. So just like we did with the friend bot, we've got a couple of different methods for getting a transaction built, signed, submitted to this test network server. So the first thing we need to do is load up our account. So let's do that. And then we'll just console log this really quick so we can look at the state of the account. So this is very similar to doing that endpoints on this single account. It's not a method, my bad. All right, so we've got our account response. It's got some information. You can see here we've got our balances, which should have those lumens with the 10,000 minus the fee that we spent that one time. So dealing with the same account on the same test network. So we've got our account. The next thing we need to do is use this account to start spinning up a brand new transaction. So we're going to set up a new transaction. And for this, we're going to use the transaction builder. And let's actually look up the transaction builder in our SDK docs. And we've actually got a nice, clean starter code snippet here that I'm actually going to straight steal. I'm not a big var guy, so I'm going to switch that to const, but potato, potato. The source, if we go back to our documentation, we can see the The source here is an account type. And lo and behold, that is what is returned when we load up our account. So this source is actually going to be the account that was returned. Clean that up a little bit. When we loaded up our account. So new transaction builder, start with the account, and then it takes an object. And that object receives a couple of different items. Move this over here. It receives a couple of different, this secondary objects, or I'm sorry, options object receives a couple of different keys. Only one of them is actually required, but we're going to use both fee and network passphrase just to be really explicit on the passphrase that we're using. And this is how we denote whether or not we're using the public network or the test network. So the fee is required, and that's that base fee. If you remember back from the laboratory, this base fee right here, we'll go ahead and set that. Which is actually, there's a nice little helper here in the SDK. If we go back down to our globals, there's a base fee, so we'll use that as our fee. And then the network passphrase is the networks, and we're going to use the test net. So we've got another one here. If we look up our networks, there are two networks, the public and the test net. And if we use network test net, it'll use our test network passphrase. Super duper. Now we've set up our initial transaction builder piece. I think I've imported networks and base fee. We don't care to create account right now. We've already got an account. We're going to do the exact same operation that we did in the laboratory. We're just going to do it with the SDK now. We're going to make a payment to ourselves. So take this public key, and the amount is going to be this 100 lumens like we did before, and the asset is the native asset. So we're using two new classes here from the SDK, operation, which I just included there, and then also asset native. Operation, if we look here, we can see we've got all these different functions in our operation class. One of those is payment, and the payments operation takes an object that has these different keys that you have available to you. We'll just be using destination, asset, and amount. Source, again, being optional, not required. It'll assume the transaction source if not included. So we'll just do destination, asset, and amount. So we already removed the source. We also have asset, which allows us to build new asset classes. And this one's going to use the native, which is going to assume the XLM native asset. You can, again, look at the documentation to see the different methods that are available on the asset class. Then we also have set timeout back from our transaction builder. This one right now is set to 30 seconds. Actually, that might be 30 minutes, but I think it's 30 seconds. But I'm going to set that to 0, and 0 will just say this is good forever. So it would be the exact same thing as just leaving these time bounds as blank. This set timeout is required unless you set up those times inside of the transaction builder. So if we go back to our transaction builder, you see there's a time bounds option. You can set the min time and the max time. And if you set that, that is effectively setting this timeout piece for the max timeout. So you can either set those inside of the option here or inside of the timeout method. Since I'm not setting it here, I will set it here. And then finally, we'll build this transaction, and this sort of finalizes the whole transaction such that we could export it somewhere else if needed. At this point, it'll be a valid transaction. So I'm going to console log this transaction, and it'll be a nice little object for us, which I don't need to console log this public key anymore. Looks like we forgot to include the transaction builder class. Kind of need that one. And then we've got a nice transaction object, but if we wanted to actually transfer this, so if you remember when we built it here, it gave us this nice XDR that you could transfer to somebody else, you can send to a user, or move around as needed, store it in a database, whatever you might need to do with it if you're not immediately submitting it right now. So there's a method to XDR once the transaction has been built, and that will give you a nice clean XDR here, which we could then, if we wanted, take into the laboratory, view the XDR, paste that in, and you can see this nice source account with the sequence number I already included, this min and max of 0, starting to look super familiar. Payment to myself for 100 lumens. We haven't signed it yet, though. So that's the next bit, is to take this transaction and actually sign it, which I'm actually going to leave this really quick so that we can see what the transaction looks like once we've signed it. So now it's going to be that transaction plus signature. We actually need to use our key pair from up above. So when we create it from the seed, take that key pair and sign it. Okay, so we get the same sort of XDR. This time it's a little bit longer because now where this is signatures array is 0. Now it has a signature of the source account that we need. And you could sign this with other accounts, it would just be invalid, right? Because this operation is dealing with this destination account is the one that's going to need to sign for it. So now that that's signed, we can actually submit it. So if we want to submit that transaction, we run our server submit transaction, and the argument that it takes is just a transaction. And now what this should do is take that whole transaction that we just built and signed and submit it to the network. And if everything works, it'll accomplish the exact same thing that the last one did, where we get a fee that's spent. This fee is actually a little bit smaller. It's only 100 instead of 1,000 because we set a smaller base fee. But the transaction submitted successfully. And if we look up this transaction in our, let's just do the operations for this transaction, we should see a successful payment of 100 lumens from ourselves to ourselves. Nice. So obviously there's more that you can do. You can chain different operations together. If you wanted, this would actually be totally valid. We just do the same thing 4 times. Let's just do 5 times. Why not? And we can submit that same transaction. It'll use a new sequence number, spin up the whole thing, sign it, and then submit it. And if we look at that transaction again on our blockchain, you'll see that there are actually a few different records this time, all for that 100 lumens, making the payment 5 times. So you can chain all these different operations. If one of them fails, they all fail. So it's nice and atomic, which is super important for transactional operations. But this is really all there is to it. You just got to chain different operations together, sign them. I mean, there's all kinds of fancy things you can, there's lots of different kinds of operations, and by chaining things together, you can do all the multi-sig stuff. Topics for another day, but at the end of the day, it's really not that complicated to actually use Stellar. In very few lines of code, you can get started submitting transactions and making payments and altering balances. The rest of it is just some reading on our developer docs and reading the SDK documentation to see what flags or keys you need to add to the different methods. But it's really quite simple to begin utilizing the Stellar blockchain without setting up anything really, just getting accounts funded, and then you can kind of take off. The next piece worth covering, though, as I mentioned, outside of just the SDKs, is actually implementing these things into this wallet, delegated signing wallet. For that, I'm going to switch over to this Stack Blitz, which kind of is a similar sort of thing, but it's more on the front end, at least for our use case, where we have a really basic application here. Looks like I've got that piece. There we go. Set up. I'm actually pulling in, so Albedo, if we were to go to our Albedo documentation here, it's open source. We can see how we would get this set up on unpackage script. So I've gone ahead and included that. I've got a reset styles just to make the styling a little bit more sane. And then the scripts to actually use this is super easy. I've just got a button, get public key. And then in my script, I'm selecting that button and adding an event listener that says, when you click on that, fire off this albedo method, get the public key, and then return the public key. So this is all documented very well here. And albedo actually has a developer playground, very similar kind of to the way Laboratory works, where we can view our public key. And then when we click this, it's going to open up a nice little modal for us. And I've already got an albedo account, but if you didn't, I would ask you to create a new wallet. And then the last step being this request to view a public key. Like, yes, I would like to actually view this public key. I'm going to enter the password for this. And then if we look at our console, it's going to console log the result here. We can see that it sends us back the public key. It actually also sends back a signature and a sign method, just so that you could send this like maybe to the back end to say, hey, this person not only says they have this public key, they've actually proved they have this public key by signing some arbitrary message. So here's the signed message, here's the signature. You can check the message against the signature to see that the public key actually has ownership of the private key as well, which is really important. Otherwise, somebody could just say, hey, here's a public key, I own this. Best way to prove that is to give them some arbitrary message and have them sign it. So albedo provides a method by proving that ownership via signature. And then from there, it's actually quite simple. All we have to do is paste in some sort of XDR. There's lots of different things albedo can do, but one of the ones that's most interesting to me is just the ability to sign arbitrary XDRs. So if we remember what our public key was, which I definitely do not, so I'm going to need to get that back really quick. And I'll spit out, okay, that's my public key. So I'm going to make an XDR, right? So this would be, let's say I don't know your secret key, thank goodness, but I do know your public key. So I'm going to fabricate or construct a transaction for you. Maybe this would happen, oops, this account does not exist yet on the testnet, so I need to actually get this funded on the network first. So this account is funded, and let's say I'm the service provider and you are using my application, and the transaction that I need signed is a payment. All right, let's do something new. Let's say we want to manage some data, and we want to put some arbitrary data on your account, and we want it to be hello world. And so this is the transaction for this account that came from albedo with the sequence number. Like, everything's right except for the signature. I need this transaction signed for the hello world to actually make it onto your account, which we'll go ahead and load up this account in a new laboratory, just to show that the data attribute doesn't have anything on it right now. I want this to have a field of hello and then world. It'll be base 64 encoded, but still it'll say hello and then the base 64 of world. But the only way I'm going to get this to work is if I can get this signed, right? Because if I try and submit this, we're going to get that we're missing authentication. There's no authorization for this change to be made for this account. So since I know the public key, I've constructed it, and now I just need you to sign it. So with albedo, I can take the XDR, send that to you, and somehow, whether it's through a direct input or an email with a link, or you can get super fancy with it, at some point, at the end of the day, I need albedo to open up. Oh, I don't think I ever saved this, which maybe it doesn't matter. I need you to sign a transaction, which is going to add a data entry of hello equals, and looks like this is a hex encoded of hello world, but that's fine. essentially add a data entry of hello world to your account. So that's telling you what it's going to do. It's decoded that XDR that it's requesting signatures for, and it's telling you what it's going to do. And then if you're okay with this change that it's about to make, you just click confirm. We put in our Albedo password again, and then bada boom, it hasn't been submitted. But if we looked up this signed XDR now on our laboratory, whoops, let's look at our view XDR. We'll see that we have the signature now, hello world, with a signature. So if this point, when we try and submit this transaction, it'll actually submit to the network just like we expected. And now if we were to refresh the account, we should see hello and then world base 64 encoded. And I can prove that to you by doing A to B, take the base 64 and turn that into a string of world. So now this account has hello world appended to it. I never had to know your secret key, and you didn't have to construct the transaction. So we have a separation of interests, but a really nice user experience. If we wanted this transaction to actually submit, there's a nice little helper flag we can add of submit true, which will both sign and then submit the transaction, which will need to generate a new transaction. So at this point, how about we create it, get the new sequence number because we just used the old one. Let's actually remove this hello world entry. Take this XDR, send that over here, say, okay. So this is going to delete the data entry, hello. That is exactly what I want to have happen. So now it's both going to sign and submit that transaction. So what should come back from our console log here is both the signed XDR as well as the transaction hash because it was submitted. So if we go back to our Stellar laboratory and we look up our endpoints for operations for transaction and we look up that transaction hash, we should see the operation where the managed data attribute hello was removed. And were we to take our public key and look this back up in our single account, we should see that the data field is now empty again. Super. All right. So obviously there's way more that we can get into on how you can use all of these things. But from here, the task is really just begin to put all of these pieces together. The Horizon API endpoints, the operations that Stellar allows within the transaction functionality, mixing that with things like the delegated signing from Albedo. You can build really any sort of payment processing application or service with a combination of these different things, which is amazing. There's no nodes to set up. You can just start coding with JavaScript in languages you're already familiar with and very quickly begin building the future of finance that we all want to see. All right, super. So at this point, I will open it up for questions. I'm going to stop sharing my screen so that I can get access back to the chat.
Cool. Yeah, there's quite a few things in chat. Probably
super.
Some are from an earlier stage than you were at. So, do you want to? Shall I read them out? Do you want to?
No, let me go back through. Where does this start? How many people have completed Stellar quests? Close to 3,000 different people have completed Stellar quests. So there's a whole bunch, and we have a really nice Discord community that will help folks. We'll be starting another one pretty soon. So quest.stellar.org for more information about that. And it's neat too, like that information is actually public. One of the nice things about blockchain, or at least the Stellar blockchain, is that it's public. So you can run analytics on our blockchain and find out how many people have completed Stellar Quest without having to rely on me. We hand out badges. So those badges are tracked in Stellar. So you just need to see how many accounts have received Stellar badges or Stellar Quest badges. You mentioned Stellar nodes and validators. What's the difference? So there are watcher nodes and validator nodes. Watcher nodes, essentially you can contribute to changes on the Stellar blockchain, or you can just watch changes. So you essentially have a database, one of those Postgres core databases, and you can observe the data, or you can actively contribute to validating changes on the database. And then there's Horizon, which is kind of this plugin that you put on top of that, which parses the state of the blockchain. So some nodes are validator nodes, other ones are just keeping an eye on it so that they have the data readily available. So rather than relying on the public instance of our public Horizon, you could spin up your own, and you won't have to worry about rate limiting or all of the things that come with using the public endpoints. Is there a Python library? There sure is. Go to developers.stellar.org, look up our SDKs, you'll find the Python SDK. Yes, I'll be sure and share the links to both of those repos that I was coding on so that you have access to those. Looks like someone pasted the link to the Python SDK. What's the best wallet to use of Stellar? That's a very difficult question to answer because it depends on what your use case is. There are lots of different kinds of wallets that support Stellar. Lobster, LOBSTR is a really popular one. There's another one called Solar Wallet. I think it might be solarwallet.io, which is really good. Albedo is definitely my favorite because it allows that delegated signing. There's another one called Freighter that's very popular. There's quite a few of them out there. But depending on your use case, whether or not you're trying to get transactions signed or just do trading, different wallets for different things. What guarantee is there that a generated key pair won't collide with an account that exists on blockchain? It's the math guarantee of what are the chances. I suppose collision could happen, but there's no guarantee other than just the mathematics behind how things like SHA-256 work. Is Stellar EVM compatible? Definitely not. It is non-Turing complete. I guess compatible, like depending on what you mean by that, yes. Stellar transactions, it's kind of, yeah, how compatible, what do you mean by compatible? There's a project that I'm working on called Turrets, TSS.stellar.org, which is bringing a layer 2 solution for smart contracts, which I assume is kind of what that question is leaning towards. So bringing a smart contracting solution to Stellar, the Stellar blockchain and the Ethereum blockchain or any sort of Turing complete virtual machine blockchain operate at a very different sort of fundamental layer. So it'll be a very different experience than you would get with Ethereum, but TSS.stellar.org if you want this concept of like a Turing complete Stellar transaction, decentralized composability. That's a very interesting project that's been gaining a lot of steam recently. So I'll be sure and check that out if that's something that's interesting to you, but it does work very differently than Ethereum, which would be, again, a topic or a conversation for another day. What is the memo type? It's going to be based off of the length of the memo. Some of them take like a SHA-256 hash. Some will take arbitrary, like you could put in hello world, but the bytes are much smaller. It really depends on what kind of information are you trying to put into the memo. Is it just numbers? Is it a hash? Is it random string? Stellar is a very concise, I would say constrained blockchain in that you can't just put loads of arbitrary data in there, which allows it to be quick and cheap, but also means when you try and get away with more arbitrary types of things or large amounts of data storage, you're going to have to get clever with it, whether that's in a memo or the managed data fields. Different things that you can do, but Stellar is ultimately trying to be really good at payments, not really good at anything decentralized or anything blockchain. So different blockchains for different things. Stellar has its own use case. They're different for the memo question. It really just depends on what are you trying to denote with your memo. What does not Turing complete mean? Whoops, using terms that people don't understand. Turing complete is essentially the idea that you have arbitrary programming. So you can kind of, anything that you want to accomplish with a computer or with a programming language can be done. So if I want to ask the question, is it raining outside? Stellar's not going to answer that question. But JavaScript could if you give it enough other inputs. So you could make an HTTP call to the Weather Underground API. And so long as the function is there, the code is there to support anything that you want to happen. If you can dream it, you can do it, sort of a thing. So JavaScript, for example, is a Turing complete programming language. Go, Python, but Stellar is not. The EVM machine, it's arguable whether or not it is. It's definitely a lot closer than Stellar will be, because there's a very limited number of operations that Stellar can accomplish, whereas with Ethereum and the virtual machine, you kind of just send it a program, and it can be who knows what, and it'll try and execute it. Are there any multi-sig management tools on Stellar? Well, there's our native multi-sig. If you look up the set options operation, there's a functionality for adding multi-sig. Multi-sig is baked in at the core of Stellar, which is fantastic and is actually the fundamental assumption or operation that's used in my Turing complete smart contract layer 2 solution that I've built for Stellar, is the concept of multi-sig. There's a lot of really cool stuff you can do once you start introducing multi-sig and weights and thresholds. If by tools you mean like a UI or something, Stellar's not a UI. And they're honestly, I haven't found too many good UIs that introduce like addressing sort of the multi-sig. There's one called Lobster Vault, which is more just adding additional signing tools to your account, which is really cool. Just to sort of protect yourself, like, oops, I leaked my secret key. You're okay if you add multi-sig with, it's almost like two-factor authentication, sort of, where you add multiple layers of security to where either no one key owns everything, it's a combination of multiple keys, or you have some master key locked away somewhere, but you have no intention of using unless your house burns down or something like that. The multi-sig functionality is super important and really cool. But I don't, depending on, again, on what you mean, like management tools, yes, probably, unless you mean UI, which again, you'd have to use some external tool that someone else has built to sort of, like, you could make, kind of like what we did with payments, you could make a UI that composes a transaction that changes the multi-sig structure of an account and then introduces that through Albedo to the user saying, hey, we're going to set up your account with this multi-sig scenario set up. If that looks good to you, sign it, sort of a thing. And that would be like maybe a UI tool. So Albedo is just a Stellar version of MetaMask. Yep, pretty much. Can we play with NFTs on Stellar? 100%. I love NFTs being built on Stellar. There's actually a great platform called Lightmint. So if you Google Lightmint NFT, you'll get a marketplace, an NFT marketplace that's really been taking off on Stellar recently. That's all about NFTs on Stellar. Fun fact, the Stellar Quest badges that you win, along with any lumens that you win, is an NFT. So you get to collect these little collectible NFTs as you complete the Stellar Quest challenges. Follow up on the EVM question, are the Stellar key pairs based on BIP39? They're not. You can use BIP39 to almost do, that would be like more of a wallet question, where if you wanted to use like a passphrase plus an index to get an indexed version of all these keys, you absolutely could do that. That's actually really common. I even think, excuse me, Albedo does that, where you enter a passphrase, I think it's a 24-word passphrase, maybe a 12-word passphrase, and then select your indexes, 0, 1, 2, 3, 4, to derive. It's just basically the idea of key derivation, where you use a single seed and then derive key pairs from that seed based off of indexing. So that's pretty common in the Stellar wallet sphere, really just in any cryptocurrency wallet sphere, where you can very quickly spin up new wallets off of the same seed. So you don't have to have a user memorizing 20 different passwords for every single key. It's a little risky because as soon as somebody gets that seed, if that were to happen, they get access to all of the keys. So BIP39, or the idea of passphrase key pair derivation plus multi-sig, is a pretty cool combination. For building, is it good to use Stellar Labs inbuilt IDE? It's good for testing, for playing around to figure out, to kind of get an idea of what are we trying to do, what operations, what order do we need to put the operations in, to kind of get a sense of what your transaction should look like, and then from there build it into an SDK. because obviously if you're running some sort of platform, you don't want, hey, user, go over to Stellar Laboratory, enter all of these values, and then submit that transaction. Like, you probably need to be using an SDK with a little bit more of a cleaned up interface, but the laboratory is fantastic for kind of getting kickstarted. I'm going to really quickly, now that we're at the end of these questions, if anybody has any more questions, feel free to type them in. Otherwise, I'm going to enter those 2 links. The first one to my run kit that I was using, and then also the Stack Blitz. And if you guys aren't using these tools, like, this is probably the best thing other than all the stellar knowledge you're getting, are these 2 great tools, particularly Stack Blitz, for actually doing kind of coding in real time in a way to share it with other people and just play around without having to set up a whole environment, which Stellar is already really nice because you don't have to set up a whole node environment and do DevOps to get things set up. But these UI tools are really starting to explode. There's another one called Auto Code. Let me getting this one for free. This one's been blowing my mind recently. And these have just been popping up all over the place. It's just a really quick way to start coding, playing around, and actually get something that's live running on the web. That could be your application. Maybe you put a custom URL in front of it, but a great way to sort of get kickstarted on some of these different experimental projects without having a desktop flooded with all kinds of weird installs and stuff. So those 3 links are going to be good ones for you. All right, any final questions? Anything y'all want to ask me? Otherwise, this has been a lot of fun. Good luck. Wish you all the best.
Awesome. Well, thank you very much, Tyler, for that presentation. And all the material will go up on Medium and on YouTube tomorrow morning. But Tyler, in the meantime, thank you very much. Everyone else, I know we're going through a lot of one-on-one calls led by Danny and trying to help you out as much as possible. So if you do want to call, just reply to your emails or reach out to us on Discord, and we will help you on a one-on-one basis as well, at whatever kind of stage of your journey you're on. In the meantime, enjoy everyone's evening. If you're watching the football, go England, and otherwise, have a good evening all. And Tyler, thank you very much once again.
You bet. Thanks so much for having me. Y'all have a good evening.
Bye.